Hello everyone, I am Ichita, working as Assistant Professor in the Department of Civil Engineering at Maharaja Institute of Technology, Mysore. In this session, I am going to discuss Module 2 of Green Building, that is Environmental Friendly and Cost Effective Building Technologies or Techniques. Particularly in this session, I am going to discuss some of the precast members which are used in cost effective building constructions. So before going to the precast members, let us see what do you mean by precast member. So precast members are basically a concrete members which are casted before going to place it in a final position. That means precast members are casted in a factory under controlled condition. So the precast members are casted in a factory under controlled condition by casting a concrete in a reusable molds or form, and then it will be cured in a controlled environmental condition. So the curing of the concrete members depending upon the type of the members. Okay. So the curing was done for 7 days, 14 days and also 28 days. So water curing will be done for the concrete members. So these precast members after cured in a controlled environmental condition, later it will be transported to the construction site and there it will be lifted up by using a machineries and then it will be erected in a exact position. Okay. This is about the precast members. So these why we are using without using conventional method of construction, why we are using precast members is these precast members are readily available. So it will reduce the cost of construction and also it will reduce the cost of construction and also cost of material, and also mainly it will reduce the time of construction. So whenever the building or a project or any type of construction work is completed within a specified time, we will go for these precast members because these precast members are structurally strong. These precast members are more durable since it is manufactured in a controlled condition at factory. These precast members will reduce the labor work and these precast members will mainly reduce the time. So that is why we are using these precast members in our cost effective building construction. Let us see some of the examples for these precast members are So example for these precast members are precast beams, precast columns, precast walls, then precast slabs, precast door and window frame, precast door and window frame, then precast manhole cover, then precast bathroom pit rings, then precast water tank and precast septic tank. So these are all some of the examples for precast members, precast concrete members. So in this particular session, I am going to discuss the two precast members, that is precast water tank and also precast septic tank. First one is precast water tank, and precast septic tank. Let us see what do you mean by water tank. As we all know, water tank is a container which is used to store a water. Either it may be a domestic purpose or commercial purpose or for industrial purpose. Depending upon the water demand, we will use the different types of water tanks. And at present scenario, it is necessary to take a measure to store and use of water. Okay. Let us see what are all the specifications which are considered while casting the precast water tank. So, some of the specifications are grade of concrete, so the grade of concrete which is preferred for casting of precast water tank is M45 grade. Then the grade of steel, so the grade of steel which is used is Fe 500 grade steel. Then another specification is earth pressure, another specification is earth pressure. So, what do you mean by earth pressure? So, earth pressure is the pressure which is exerted by the soil is called as earth pressure or lateral earth pressure. So, the what are all the pressure which is exerted by the soil is called as lateral earth pressure or earth pressure. Here there are two types of tanks, one is light duty tank, another one is heavy duty tank. So, light duty tanks so there are two types of tank, light duty tank and heavy duty tank. So the light duty tank is nothing but where the quantity of water stored will be more. So the light duty tank withstand or it can take the surcharge load of 1 ton. So the surcharge load is nothing but the what are all the load which is exerted by the soil, the vertical load exerted by the soil, it can take up to 1 ton. So, the heavy duty tank is nothing but where the quantity of water stored will be more. So, the heavy duty tank can take surcharge load of 40 tons. So, the tank will resist the surcharge load which is exerted by the soil, that is 1 ton and 40 tons. So, the another specification is uplift. So, since the precast water tanks are laid underground, laid in the underground position, we will consider the uplift condition also in designing. So, all the water tanks, all the precast water tanks are designed no uplift condition, even when the water tank is fully submerged, fully filled with water, and also even when the water tank is empty. So, water tank is designed for no uplift condition. So, water tank should be designed as no uplift condition even when the water tank is fully submerged and also even when the water tank is empty. Since it is laid in a underground, we will not lift the water tank at any circumstances. So, another main specification is the coating of the water tank. So, the coating of the water tank is necessary in order to avoid the cracking of the concrete and also in order to avoid the leakage of the water. These are the main important things why we are using coating for the concrete concrete water tank is in order to avoid the leakage of water and also in order to avoid the cracking of the concrete. So, it is necessary to coat both internal and external of the water tank. External coating, so the external coating is done by using coal tar epoxy paint. Coal tar epoxy paint. So, the external coating of the water tank is done by using coal tar epoxy paint. So, why we are using this coal tar epoxy paint is it has very good resistance in both marine condition and also for subsoil condition, and also this coal tar epoxy paint has very good chemical resistance. So, it has a very good chemical resistance property and also it has very good abrasion resistance and also water resistance. So, it will avoid the leakage of water. It will also reduce the corrosion of the steel reinforcement which are provided in the water tanks. What are all the chemical effect caused by the steel reinforcement that will avoided by using these coal tar epoxy paint. Okay. So, the internal coating, another is internal coating. So, the internal coating is done by using waterproofing material. So, that is arsenic cementitious material is used as waterproofing material. So, the arsenic cementitious material used as waterproofing material for internal coating of the water tank. So, one of the example for that arsenic cementitious material is Dr. Fixit Pidifin 2K. So, this is one of the cementitious material which is used as waterproofing material for internal coating of the water tank. So, the main purpose of using coating material in water tank is to avoid the leakage of water and also prevent the water tank from cracking and also prevent the water tank from corrosion. Okay. These are all the main purpose of using coating in a precast water tank construction. So, these are all the specifications which are considered while casting the precast water tank. So, let us observe in the slide, this is an example for concrete rectangular water tank. So, the different shapes of water tanks are available. We can cast what are all the shapes we required, rectangular, cylindrical or etc. What are all the shapes we required, we will cast the water tank in that shape by using a molds. So, let us see in slide, this is an example for rectangular concrete precast water tank. So, it is a best example. So, where there are plenty of companies water tanks are available in market. So, the only thing is we will purchase it and we will install in our building or our construction site. What are all the specifications we required, what are all the sizes and shapes of water tanks we required, we will purchase, we will give the order for that and we will purchase it and then we will install in our, directly installed in our building or construction site. So, this is an example of one of the rectangular precast concrete water tank. It has a weight of 60 kg and thickness. So, thickness of this rectangular concrete water tank will be 2 inch thickness. Then dimension of this rectangular concrete water tank will be 4 feet by 2 feet. So, the dimension of this rectangular water tank will be 4 feet by 2 feet and it has a storage capacity So storage capacity of this water tank will be 500 liters. 500 liter storage capacity. The cost of this water tank will be around 3000 rupees. The cost of this rectangular precast concrete water tank will be 3000 rupees. So this is about this precast concrete water tank. So we will cast the precast water tank for 500 to 1 lakh storage capacity. Okay, 500 to 1 lakh storage capacity we will cast it by using molds in a factory. So instead of using brick masonry water tank, we will use here is precast concrete water tank. So these precast concrete water tanks are structurally more safer than the brick masonry water tank. So we can compare the cost of both the normal masonry, brick masonry concrete tank and also this precast water tank. So this precast water tank will more durable and it also more structurally safer than the brick masonry water tank. So using of this water tank, we will directly place it in our exact location. It will reduce the construction time. Okay, this is about the precast water tank. So let us come to the another precast member, that is precast septic tank. So another precast member is precast septic tank. Before going to the precast septic tank, let us see what do you mean by septic tank. Septic tank is an underground chamber made of concrete through which domestic wastewater will be flow for basic sewage treatment. So what are all the waste which will be generated through our buildings? So what are all the waste will be generated in our building? Domestic sanitary wastewater generated by our bathrooms, kitchens and also wash basins. These are all the sources of domestic sanitary wastewater. What are all the wastewater which is generated by bathrooms, kitchens, so and also laundries and also wash basins? These domestic sanitary wastewater, raw domestic sanitary wastewaters are passed into the septic tank for the basic sewage treatment. By treating this domestic wastewater, it will be used for some irrigation or gardening purpose. The main intention of this septic tank is to treat the wastewater, okay, in order to treat the wastewater, in order to minimize the wastage of water, reduce the wasting of water. So these septic tanks are watertight tanks and it will be buried in a underground. Okay, these septic tanks are watertight tanks because it is made up of concrete and it will be buried in underground. So let us see what are all the materials which are required for constructing these precast septic tanks. So what are all the materials which required for constructing these septic tank are, the main thing is the steel, reinforcement and also the concrete. So what are the grade of concrete or the type of concrete which we are used in casting precast septic tank? So that is concrete. So the grade of concrete here we are using is should not be less than M20 grade. So the concrete which we are using here is should not be less than M20 grade. So based on the codal provision, highest standards, based on the highest standards, we are the minimum cement content, will be, so the minimum cement content based on the IS standards will be 400 kg per meter cube. And next thing is water cement ratio. The ratio of the mass of water to the mass of the cement which is present in concrete mix, that is called as water cement ratio. The water cement ratio preferred for this type of work is 0.4 based on IS standards. So this is about the concrete and also water cement ratio which we are prefer. So the next material which we are used is aggregates. So the main in concrete, the concrete is made up of cement, aggregates, both coarse aggregates and fine aggregates, and water. It's a mixture. Concrete is a mixture of cement, coarse aggregate and fine aggregate. So the aggregates which we are used in casting the precast water tank, the maximum nominal size of the coarse aggregate, the maximum nominal size of the coarse aggregate should be 12.5 mm. So the what are all the coarse aggregates which we are used, what are all the coarse aggregates which we are used is should not be more than 12.5 mm, it should be 12.5 mm. Then the fine aggregate which we are used in concrete, the fine aggregate which we are used in concrete should be natural river sand or either it may be a M sand. So the natural river sand what we are used here, it should be passing through 4.75 mm IS sieve. So the fine aggregate what we are using for preparing a concrete mix, that should be passing 4.75 mm IS sieve. This is about the aggregates. Then another material we are used is water. So the water which we are used, it should be follows or it should fulfill the IS standards 456 19787. So the water which we are used for preparing a concrete mix should fulfill the requirement of IS standards of IS 456 19787. This code requirement we will fulfill. That means the potable water which we are used for casting the concrete member. So the another material which we are used is, that is pozzolanic material. So pozzolanic materials used in concrete, the main intention of using pozzolanic materials in concrete in order to reduce the cement content in a concrete. So by using pozzolanic materials, so pozzolanic materials will have the same qualities of the cement. What are all the cement have the characteristics, it should also possess the same characteristics of cement. So let us see some of the pozzolanic materials which we are used in casting a concrete is partially replacement of cement. The main intention is in order to reduce the cement content by partial replacement of cement, partial replacement of cement, we will use the pozzolanic materials. So some of the pozzolanic materials which we are used in concrete mix are silica fume, rice husk ash, GGBS, fly ash. So GGBS is nothing but ground granulated blast furnace slag. So some of the pozzolanic materials are fly ash, silica fume, rice husk hash, RHA is nothing but rice husk hash, and GGBS is nothing but ground granulated blast furnace slag, and also metachyline, so these are the some of the pozzolanic materials which we are used in partial replacement of cement in order to reduce the cement content, in order to reduce the cost of the cement in concrete mix, preparing a concrete mix. So, we will use some of the pozzolanic materials. So, since it has a silica content in it, so it will possess the same qualities, same properties of the cement. Okay. Then based on the IS code standards, we will use these materials as the partial replacement of cement while preparing a concrete mix. So, next material which we are used is admixtures. So, the admixtures, there are two types of admixtures. One is chemical admixture, what I already told you in pozzolanic materials, and also the chemical admixtures. So, the chemical admixtures used in concrete is superplasticizer, why we are using superplasticizer is in order to improve the workability of the concrete. In order to improve the workability of the concrete by reducing the water content, we will use the superplasticizer. So, this superplasticizer will reduce the water content, water requirement, it will reduce the water requirement in a concrete by increasing the workability of the concrete, and also it will improve the setting time and also hardness of the concrete and also durability of the concrete. So, based on the codal provisions, we will use the superplasticizer percentage in the concrete mix. So, the main thing or main material which we are used in concrete design mix is reinforcement. So, reinforcement is the main thing. After cement, reinforcement is the main thing in concrete mix. So, why we are using reinforcement in a concrete mix is in order to strengthening the concrete. In order to strengthening the concrete, we will use reinforcement. Okay. As we all know, concrete is good in compression but weak in tension. In order to improve the tension property of the concrete, we will use steel reinforcement in a concrete members. Okay. In order to improve the tension property, tensile property of the concrete, we will use steel reinforcement in a concrete mix. So, here in septic tank construction, so in septic tank, precast septic tank construction, we will use steel bars or steel wires. So, in precast septic tank construction, casting the precast septic tank, we will use steel bars or steel wires as a reinforcement. So, these are all some of the materials which we are mainly concentrate while preparing a precast septic tank. So, let us come to the working principle of septic tank. So, let us observe in the slide. The slide shows the figure of septic tank. Okay. So, septic tank consists of inlet and two chambers and outlet and also baffle. Okay. These are all the parts of the septic tank. So, what are all the waste which will be generated in your buildings? Okay. So, mainly these septic tanks are installed in institutional buildings. That means institutional building means schools, colleges and hostels and also hospitals and apartments and also in malls. So these septic tanks are mainly installed in these buildings. So where the generation of waste, domestic waste or sanitary waste water will be more. The quantity of domestic sanitary waste water generation will be more. In that places we will install the septic tank in order to treat basic treatment of that domestic water. Okay. And also these septic tanks also installed in some of the buildings and also some of the villas also, where we are installing in order, the main intention is to treat the wastewater. So let us observe in the slide. The septic tank consists of inlet and also two chambers, baffle and also outlet. So what are all the waste will be generated in your buildings, any type of the buildings. So what are all the waste will be generated in your building, that waste will be passed through pipeline to the septic tank through inlet. So the what are all the waste collected or outletted from your buildings will be collected and it will be enters into your septic tank through the inlet pipe. So through the inlet pipe the domestic wastewater, domestic sanitary wastewater will enters into your septic tank. In septic tank the wastewater will segregated in 3 layers. Okay. In septic tank the wastewater will be segregated in 3 layers, that is segregation, so in septic tank the waste will be segregated in 3 layers, that is scum, another one is effluent, another one is sludge. So what are all the waste, domestic waste water enters into your septic tank will segregated in 3 layers, that is top layer is called scum and effluent and also sludge. So what are all the waste contains? So the wastewater usually contains both solid heavier particles and also lighter particles. So the solid waste both lighter solids and also heavier solids. The lighter solids, that means the oil and grease which float at the top of the chamber. So what are all the lighter particles, lighter solid particles are there, that means oil or grease which will floats on the top of the septic tank, okay, which will floats on the top of the chamber, first chamber or second chamber. The number of chambers mainly depends on the region and the amount of waste. So quantity of waste which will generated, based on that we will placing the chambers. The number of chambers which mainly depends on the amount of waste which will be generated. Okay. So the what are all the lighter particles which are there in your wastewater, that will floats at the top of the chamber, that is called as scum. Okay. That is called as scum. What are all the liquid waste in your septic tank? What are all the liquid waste are there in your septic tank are called as effluent. Then after floating the lighter particles, as usual the heavier solids will get settled at bottom of the tank. Heavier solids will settle or accumulated at bottom of the chamber, that is called as sludge. So whenever your domestic waste, sanitary waste will enters your septic tank, it will segregated in 3 layers, that is scum, effluent and sludge. So what are all the heavier solids will settle at the bottom of the tanks, that is called as sludge. So by naturally present, so the naturally present microbes which are in your septic tank. So, as usual the naturally present microbes are there in your waste. So, these microbes will start degrading. What? Oh, okay. These microbes will start degrading your waste by eating it up. So, naturally presented microbes in your septic tank will start degrading the sludge. Sludge is nothing but the accumulated solid particles, okay, the residue which will collected or settles at bottom of the tank is called sludge. So, these naturally presented microbes will start eating that sludge by degrading it up. So, this degradation will start by anaerobic digestion process. It will start eating up the sludge. So, the water will be partly treated, then simultaneously which will enters to your second chamber, another compartment. So, in another compartment the amount of solid, heavier solid waste will be less because it already accumulated in first chamber, okay. So, what are all the solids which are accumulated in first chamber, the partly treated water enters to your second chamber. So, in second chamber usually the amount of solid waste will be less. So, similar process in second chamber also, what are all the lefted floating particles, lighter particles are floated at the top, that is called scum as usual, and the heavier solids remaining lefted, heavier solids will settle at the bottom of the tank. So, that is called as sludge. So, similar, what are all the procedure it will follows in a first chamber, same that in second chamber also the heavier solids, remaining lefted heavier solids are settled at the bottom of the tank, okay. So, in second chamber we will place a filter also in order to filter that water. So, after settling of the solids in your second chamber, so similarly in second chamber what are all the microbes present in your second chamber will start degrading the waste which are accumulated at bottom, and then it will eating up the waste. So, it will start eating up the waste, that is nothing but sludge, and it will degradation will be takes place. So, by anaerobic digestion process. So, then the treated water, basically treated water will outletted through the outlet pipe and it will be supplied to your irrigation land or gardening purpose through the outlet pipes. This is how exactly the septic tank works, okay. So, what are all the waste? Sludge it will accumulated at, or it will, the residue which will accumulated at bottom of the tank will be heated by the microbes and degradation will takes place. The basically treated wastewater will be passed through or outletted through or distributed to your irrigation land or gardening purpose. So, the wastewater which is treated, basically treated, this is a basic sewage treatment process. So, okay, this is a basic sewage treatment process. In this process, the basically treated water we can use only for gardening purpose and irrigation purpose. This treated water, it is not suited for drinking purpose. This is how exactly the septic tank works, okay. So, what are all the waste? Sludge it will accumulated at, or it will, the residue which will accumulated at bottom of the tank will be heated by the microbes and degradation will takes place. The basically treated wastewater will be passed through or outletted through or distributed to your irrigation land or gardening purpose. So, the wastewater which is treated, basically treated, this is a basic sewage treatment process. So, okay, this is a basic sewage treatment process. In this process, the basically treated water we can use only for gardening purpose and irrigation purpose. This treated water, it's not suited for drinking purpose. It mainly used for irrigation and also gardening purpose. So this is how the septic tank works. The main intention of using septic tank is to treat the water and also reduce the wastage of water by managing, by treating it up, and it will be recycled and also reusable, okay, partly recycled, and it will be reused for our gardening purpose and also for our irrigation purpose. So in this session I will discuss the two main precast members, that are precast water tank and precast septic tank. So the main intention of using these precast members are in order to reduce the time of construction. So by using these members, by using these precast members, the construction time will be reduced by rapid fastening of the construction work. So it will fastens the work. So whenever we will have a certain specified time for completing our project or our building or any type of work within a specified period of time, we will go for these precast members. These precast members are also more durable than the conventional members which we are casted in exactly at the place of site. So what we are constructed exactly at the site, rather than we are using these type of materials for cost effective. And also these precast members, both septic tank and water tank, are available in markets, whatever the sizes and whatever the shape of the precast members we required for our construction site, we will directly give an order for that and we will purchase it, and directly it will be shifted for our exact location of our site, and we will erect it in a exact position. So by this process it will reduce the labor cost and it will also reduce the material cost and construction cost also. These members are more durable than the conventional materials since it is casted in a controlled condition at factories. So these are all more durable, okay, than the conventional materials. So this is why the main intention is to reduce the cost of construction. So within a specified time we will complete this project. So this is why we are using precast members in cost effective building construction.